Hi everyone. For this piecewise defined function, we're going to find the domain, locate any intercepts and graph it, and find the range by looking at the graph. We're also going to evaluate it and also test for continuity. And basically, before we get started, you look at this right here. This is your domain. So it's saying your domain, this is your domain, this is your range, your y, this is your x. The domain includes all real numbers that are less than 0, and for this piece, all real numbers greater than or equal to 0. So that just means your domain is all real numbers. So we took care of that. I want to test for continuity first. So based off our definition of continuity here, we want to know if these three conditions apply. So they have to meet all three conditions a function does to be continuous in this order. So your C is this part. This is your C because this is where the graph is changing around 0. So it's changing here on the left-hand side and it's changing on the right-hand side. So our C equals 0, and we just want to know if we have an f of C. So if you plug f of 0, that means we have to plug it in this lower portion. So that's going to be 3 times 0 plus 2 equals 2. So it does exist. We do have a value at 2. That's your y, by the way. All right, now we're going to test our limit to see if we have the limit. And let me explain what that is. So basically, you're writing the limit as x approaches 0 from the left of our function or our graph. That should equal the limit as x approaches 0 from the right of our graph. If it doesn't, it's going to be discontinuous. So what that means is, as you're approaching 0 from the left, all right, what's the graph doing? What is it getting closer to the y? So if you notice here, that means these are all numbers less than 0. Now, if you approach it from the right, all right, what is the graph doing on this side of the 0? And if you notice, these are all numbers that are greater than 0. So that's what we're going to test to see if they equal each other so they can connect. So from the left, that is, let's do purple, this one. So we're plugging in 0 into that x. So when you plug in 0 cubed, that equals 0. Now let's see from the right. So from the right, that we're going to plug into this one, and that equals 2. We already did that one. So we have 0 equals 2, which doesn't add up. So the right hand and the left hand side limits don't equal each other. Therefore, the limit doesn't exist. Therefore, the condition 2 fails. That means the graph on the right is kind of approaching 2 right here, but the graph on the left-hand side is approaching 0. That means there's something, and I don't know what the graph is yet. We're going to graph it. That means that it's not continuous, and that's what we're going to show next. So let's graph it. First thing I want to do is graph my C portion at 0. So you plug in 0 for this first part, and you get 0, but it can't equal it. Now let's plug in -1. You plug in -1, that's going to be -1. So that occurs there. Plug in -2, that's going to be -8 down here. And remember, if it's not linear, you have to at least plug in 3 points, which we did. So we're starting very close to 0 here without equaling it and going down. And that's the left-hand side of the cubic function. So that's what's going on the left side of your 0 here. Now on the right side of 0, what do we have? Well, at 0, you're going to plug in 0, and you get 2. That's your y-intercept. All right, and then since it's linear, we only need to plug in one more point. If you plug in 1, that maps to 5. So 3 times 1 plus 2 is 5. So that maps to 5 right here. Our slope is 3. Ugh. Our slope is 3. So basically, that's just a straight line. You only need to plot 2 points for that. So see what's happening. This is discontinuous because if I start down here and start graphing this, I have to pick up my pen and go to here to finish the graph. So it's not continuous. And that's why condition 2 didn't hold, because the limit as x approached 0, this went to 0, your y is 0, but the limit as we were approaching right here to 0 went to 2, so your y was 2. And there's a big jump here. That's called a jump discontinuity. Okay, you already can see from the graph that we're using all the x's. So x's is all real numbers, or you can write it like this in interval notation. Your range, let's look at the range. So what's going on with the y? We're starting at negative infinity, and we're going to 0. So that's negative infinity, but it can't equal 0. And then you use the union sign, which means or. We start at 2 on the y, and then we go to infinity. So that's your range. Okay? And what else? Intercepts. We only have one intercept. It's the y-intercept here, which is 0, 2. There's no x-intercepts because this is open. All right? And then we have to evaluate. So negative 1 belongs to this one. So negative 1 cubed equals negative 1. 0 belongs to this one. So you plug in 0, that's 2. That was your y-intercept. And you plug in 1, you get 3 times 1 plus 2. That equals 5. And that's it. Thank you. Have a nice day. Bye-bye.